Okay, question 3. What is the maximum bending moment value for our UDL here? So we've got a UDL which is worth 10 newtons per meter. It's 8 meters long, so that's going to give me 10 times 8. So it's going to give me 80 newtons total weight. So if I put this on two pivots either end, our AT will get 40 newtons that side, 40 newtons that side. I'm obviously expecting the maximum to be occurring at this position here in the middle. So can you work out what the maximum bending moment is basically in the middle? Pause the video, have a go working it out, and then press play and show the answer. Right, so what we're going to do is we'll start looking at what the bending moment is in an arbitrary position somewhere along our beam here. So let's imagine we do some sort of cut here, and we're going to look at X, and we start saying to ourselves, what bending moments can we see? Well, that's going to be my pivot. What's the bending moment I can see left of me? So we've got the 40 here. That's going to go in a clockwise sense around this pivot. So we've got 40x. Then we've got the partial section of the UDL left of us. So we want to find the weight of that UDL left of that line there, I'm calling it the XX line, and the distance to its midpoint, which will be there. Okay. So that can be written as 40x. We can say that the weight is going to be the UDL times x. To get to the midpoint will be, well, to get from here to here will be half x. Let's tidy that up. So put in our numbers, we've got 40x, take away 10x times by half x. So we've got a quadratic appearing. We could tidy that one up and we get 40x, take away 5x squared. So that's going to be the bending moment formula. So that's going to give me this kind of quadratic profile. And then the maximum is going to be happening at halfway along. So I could just substitute in 4 here. And when you do, substitute in 4, so you're going to get 40 times 4, so 160. Take away 5 times 16. Well, that's not so easy. 5 times 16, it's 8 times, sorry, it's 10 times 8. So that's 160, take away 80. So we get the answer 80. So the maximum will be 80 kilonewton meters in the middle. Right, now that is a good point to reflect on that answer, because you've got how much weight here? 10 times 10 newtons per meter times 8. So you've got 80 newtons worth of weight. How far is it from one pivot to the middle? 4 meters. So if this was just a cantilever of total weight, it would be 80 times 4. So that would give me 160 kilonewton meters. Actually, I've written kilo there. There's no kilos here, is there? So that's a bit of a mistake there. So I've got 180 kilonewton meters if I put all the weight concentrated from my UDL in the middle, and I took away one of the pivots. So there's 4 times more bending moment in the equivalent of a cantilever. Okay, and if you compare that to, say, the case where we were doing a concentrated load, you notice that what's happening is that with concentrated load compared with cantilever, the cantilever is twice the amount of bending moment. Okay, and for a UDL, where we're distributing the weight completely on the beam, it's 4 times the amount of bending moment. So that kind of tells us something, in particular when we want to come to doing things with structural design. Yeah, so I didn't actually say kilonewtons, I said just Newton meters. So slight mistake with my units there, but otherwise okay.